In 3.1, we're looking at the atom, how it started out as an idea and ended up as a scientific theory. If we look at this picture and we start out looking at the red sphere, that's kind of the first concept of the atom with John Dalton, and we'll work our way up to what the model of the atom currently looks like. So this started with Democritus around 400 BC. He was a Greek philosopher, and he wondered, what is everything made of? He was thought of as the laughing philosopher. He was always happy and joking. So he came up with this theory that all of nature was made of these basic particles called atoms. And this idea stuck around for almost 2,000 years. So most of modern history was thought on this basic principle of everything's made of little particles. So by the late 1700s, chemists are accepting this modern definition of what we know of as an element. Different properties making up all of nature. By the late 1700s, 1790s, quantitative analysis became more commonly available. And by quantitative analysis, we're looking at ways to measure things. They started having instrumentations so they could find mass and things like that, scales, and scientific instruments that they may not have had before this time. So that allowed them to come up with new discoveries based on different investigations that they were carrying out. One of those was the law of conservation of mass, which says that mass cannot be created or destroyed by a chemical reaction or by a physical change. So basically, whatever mass you start out with in a chemical reaction, after the reaction, you will still have that same total mass. Then we'll look at John Dalton, and he developed what's called the atomic theory with principles that explain how atoms work. And at his time, his atomic theory was very solid for what evidence they had. So first of all, he says that all matter is composed of atoms, which we still know is true today. Everything is made of some type of atoms. Number two looks at the fact that atoms of a given element are identical in size, mass, and properties. Atoms of different elements are going to have different properties. So looking at this, if I have a hydrogen atom, he's saying that no matter what, the hydrogen atom is always going to be the exact same size and mass. We now know that you can have a little bit different mass within the same type of atom, but we'll look at that later. But he was very close for the time. 3, atoms cannot be subdivided, created, or destroyed. Again, at that time, that was a very good theory. Atoms can be subdivided, we know now, into protons, neutrons, and electrons, and smaller properties. Number 4, atoms of different elements combine with simple whole number ratios to form chemical compounds. We can put different types of elements together to make new compounds, and yes, this is true. And number 5, in chemical reactions, atoms are combined, separated, or rearranged. And again, this is true. So the modern atomic theory makes up for a few of these things that we were able to find discoveries on as time has gone on.